Hello everyone, for this tutorial video I'd like to discuss how to figure out irregular prisms, which have a vast variation in their exact shape, just like irregular polygons in 2D geometry. An irregular prism is a prism where the two equal bases are irregular polygons rather than regular. This means the bases can be any shape at all, as long as its bases do not have all exactly equal lengths. But because it is a prism, the shapes all have to follow the constraint of the top and bottom shapes being equal to each other in terms of their perimeter and area. Just like the area of an irregular polygon must be broken down on a case-by-case basis, this is exactly as true for the surface area of an irregular prism. There is no convenient formula that you can derive that works for them all. We can see that if we decompose it into its surface area, that the area of one of its bases would be the bottom area, and so we unfold the shape with reference to that. We can see visually why the simple formula for regular prisms doesn't work here, is that even though the two bases still have equal areas, the sides no longer have equal areas with reference to each other. So for example, some of the rectangles will be bigger than the others, which was not true for regular prisms. However, even with the messy unpredictability of irregular prisms, in terms of their surface area, we can still see a convenient volume formula is the area of one of the bases times the height, because in any prism, the cross-sectional area is always the same regardless of the height, regular or otherwise. Now that we have figured out the surface area and volume of irregular prisms, we can transition our studies away from prisms and toward the study of the other common category of 3D shapes made out of polygons, which are pyramids. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.